We're gonna solve an question from the calculus Transcendentals books, which is by James Stewart. You guys find a link in the description if you want, and we're gonna solve the question 37, which says find f of g, g of f, and f of f and g of g and their domains. So let's write the question. We have the f of x equals x plus and g of x equals x plus 1 and the denominator x plus 2. Yes, so let's find the f of, what's the first requirement? F of g. So let's find f of g of x. So what we're gonna do is, instead of writing the x's for the regular x's for the f of x, we're gonna substitute it with this value, which is g of x. So we will end up, instead of writing this x, we're gonna write this x plus 1, x plus 2, and then this is our plus sign, the same plus, and then the 1 is same, but instead of writing x, we're gonna also write x plus 1, x plus 2. So, and as you guys know, the denominator of the denominator is will be raised to the numerator, so we will get this, which is x plus 1, x plus 2, plus x plus 2, x plus 1. So, and after that, we're gonna combine these two to get one denominator instead of making two, and we will get value like this. And I'm gonna skip every operation and go to the last operation to save the time. And this is what we get in our final operation. And if we want to get the domain, we can't divide by 0, so we don't want to get 0 over here. Oh, sorry about that. The result disappeared. So let me write the result again. And we have the x plus 2, x plus 1, and we want to get the domain, and we don't want to divide by 0. So when does our denominator get 0? It gets 0 when the x equals minus 2, because minus 2 plus 2, we're gonna get 0, and we also gonna get 0 when the x equals minus 1. So we're gonna say the domain is all x's such that x doesn't equal 2 and x doesn't equal, or minus 2 and minus 1. So this is our domain, and this was the function that we find. And let's solve another one from the requirement, and we're gonna go for the g of g. So let's write our g of x first. G of x equals x plus 1, and the denominator x plus 2, and we want to get the g of x. And what we're gonna do is instead of writing x, we're gonna write the whole g of x. This is instead of the x, as you guys know, plus 1, and over here x plus 1 plus 2, and if we do some arithmetic operation, we're gonna get this value. And domain over here, we don't want to divide by 0, as we said, so this side can't be equal 0. And when does this side equal 0? It's equal 0 when we have the x equals minus 3 or 5 divided by 3, because the 3 will go with the 3, and we just left with the minus 5 plus 5, we're gonna get 0. So x cannot equal to minus 5.3. And over here, this is a little bit tricky. We didn't finish our domain. If you look over here, we did finish this part, but our domain also can't equal any values in the g of x when the denominator is 0. We don't want to end up with the minus denominator or 0 over here. So when does we gonna end up with the 0 denominator? Is when x equals minus 2. So x also can't equal minus 2 because of that, because it's a g of x. So this is just was the tricky part about this question. And